Page IN 26, lesson IN 5 is on rate of change in slope. And this kind of goes along with some things we've talked about. It goes along with unit rate, constant and proportionality, things like that. So if you look at example 1, Maya and her father are building a tree house. The roof will have a 9 to 12 pitch. That is, for every 12 inches of horizontal distance, the roof rises 9 inches. How can Maya determine the height of the roof at its peak? So if you look at the picture here, kind of if we go the opposite direction of what the book's doing, we could think about this roof. I'm just going to redraw this picture up here. And so basically, if we go up 9 inches and then over 12 inches, that gets us to another point on the roof. If you'll notice on the picture also, we've got a 6-foot span going from the end to the middle. So since everything else is in inches, it might be good to get that in inches as well. So 6 feet. If we multiply that by 12, that would be 72 inches. So this is 72 inches here. There's different ways you can do this. One way you could figure out that missing value would be, you could look at this as similar triangles. So this is 12 inches and 9 inches. And then this is 72 inches. And this is what we're trying to find. So one thing you might notice, if we go from 12 inches to 72 inches, this is 6 times bigger. By the way, the reason we know these are similar, they both have right angles. This angle is the same because we're using the same exact part of the roof. And then, so if those two angles are the same, then the other angle is the same as well. And so if you remember, we talked about on triangles, if the angles are all the same, then the figures will be similar to each other. Anyway, so going from 12 to 72 is multiplying by 6. So we'll do the same thing here. So 9 times 6 would make that equal to 54 inches. So the height here is 54 inches, or that'd be, what, 4.5 feet. Another way of looking at it is we can make a table. So they said go up 9 and over 12. And then they just made a note that 9 over 12, if we do like a y over x like we've been doing, that reduces to 3/4. And then if we go up another 9 and over another 12, that takes us to 18, up 18 and over 24 altogether. And that reduces to 3/4. If we do that again, up 9 and over 12 takes us to 27 over 36, which reduces to 3/4. For some reason they skipped one here. Up another 9, that would be 36, and over another 12, that would be 48. And then that would reduce to 3/4. And then they get back on track here. If you go up another 9 and over another 12, that would be 45 over 60. And that also reduces to 3/4. So it's like overall, basically, you could say you could just go up 3 and over 4. And technically, you know, to get to the 9 and 12 that we had, if you go up 3 and over 4, up 3 and over 4, up 3 and over 4, if you do that 3 times, altogether you went up 9 and over 12. So you could actually just keep going up 3 and over 4, and that would take you to any point along this roof. So this brings us into the idea of slope. The book talks about this line that they've drawn here. It shows the steepness of the roof. So slope, one way of looking at it, it's a ratio of rise over run. Rise over run is one way of looking at it. Another thing with slope is it tells us how steep a line is and what direction it's going. So we'll talk about, as we learn more about slope, what the number is just by the number part of the slope, it's going to tell us how steep the line is. And then there's another part we'll talk about in a little bit about the slope that's going to tell us what direction it's going in. So if you look at the picture here, again, not a fan of how the book's doing this because we're doing really y over x, but we could do up 9 over 12. Here we went up 27 and over 36. And like the book showed earlier, those all reduce the same. Okay, these are similar triangles, so we're going proportionally the same for the x and the y each time. Another way of looking at slope is change in y over change in x, rather than rise over run. The reason I talk about it this way sometimes, change in y over change in x, we'll get into it a little bit later, but sometimes the graph actually doesn't rise. It doesn't go up, it actually goes down. So to me, that's not really a rise if it's going down. It's more of a fall. So just in general, we could just call change in y, it's either going up or down, and then change in x. So if you look at the Jack graphs, how far he plans to bike during a 3-day charity ride, find the slope of the line. So if you look at this, again, don't know why they're doing it this way, but we can look at these points. We can look at what our x and our y values are, and we can look at how far do we go up and how far do we go over. In other words, what's my change in y and what's my change in x. So the change in y, if you think about the y values, we went from a y value of 60 to a y value of 90. So from 60 to 90, that's going up by 30. To show work for that, we could say, well, let's do 90 minus 60. Okay, always good to show work so we can show people what we're doing to get our numbers instead of our numbers just magically appearing out of nowhere. And then our x values, we went from 2 to 3. So from 2 to 3, we went over 1. So how do we get 1? Well, we could get that by doing 3 minus 2. We'll talk about as we go along here. With our y values, we started with 90. Whatever y value you start with for finding your change in y, you have to start with the same x value. So if I started with 90, did 90 minus 60, for the x's, then we would need to do 3 minus 2. So anyway, that works out that my slope is 30 over 1. And again, kind of a corny way to help you remember this, but if you look on our graph, we went up 30 and over 1, and our slope is 30 over 1. Okay, 30 over 1, that's the same thing as 30. So we can put that over here. Slope is 30 over 1, so the slope is 30. And what we can think about also with that 30 is if you look at your units, for the y it was miles, and for the x was days. So what that means is 30 miles per day, 30 miles per 1 day is how far he's biking. At the bottom of the page, the convince me, it says, how do the unit rate and the constant of proportionality relate to the slope of the line? So unit rate, constant of proportionality, and slope. Well, our slope we found was 30. The unit rate we just talked about was 30. Our constant of proportionality, if we did y over x for any of these, since it's a straight line that goes through 0, 0. For example, if you did 60 divided by 2, that would be 30 also. So for the convince me, we could say they are the same. All three of those are the same thing. Okay. Now, again, slope we can do for any line. Constant of proportionality, it has to be proportional in order to do that one. So in other words, we can't always just do y divided by x, and that's why we worked this out over here. Because what we just did over here always works. If you just do a y value divided by an x value, that only works if it's proportional. Example 2, the graph represents the depth of a diving submarine over time. At what speed is the submarine descending? So if you look, they've got a couple points kind of plotted out for us here. One of those points is 5, negative 400, and the other one is 10, negative 800. So what we're going to do, we're going to find our slope, which is the change in y over change in x. Our y values here are negative 400 and negative 800. So if we went from negative 400 to negative 800, we went down 400. That's a negative 400. You can see in your book they've worked that out. And then the x's, we went from 5 to 10. So from 5 to 10, we went over 5. So again, that's why I don't call it rise over run, because this one's falling and then running. So change in y is negative 400, change in x is 5. And then if you look off to the side where they worked this out, they've got this as negative 400 over 5, and then when you divide that out, you get negative 80. So the slope of the line is negative 80, and what that tells us, if we think about this problem, if we look back at our graph, it means the submarine is descending at a rate of 80 feet per minute. It's going down 80 feet every minute. If you'll notice on this problem, the slope was negative, and the question here says, what do you notice about the graph of a line with a negative slope? So this was a negative slope. The ones on the page before this were both positive slopes. And so if you look at that, actually what's happening is a negative slope. If you look at the line of a negative slope, it is going down. The line is going down if we have a negative slope. Okay, so kind of like this. If we have a positive slope, the graph is going up like this. Okay, to help you remember negative slope and positive slope, here's the thing. I don't know if I came up with this or not, can't remember, but anyway, if you take that negative slope, we can make that into an n for, if I can spell it right, negative. And then down here, have to go a little bit creative. We can make that into a p for positive. Okay, so just with what we've talked about so far, we can now just look at a line and automatically tell if it's going to have a negative slope or a positive slope. Negative slope going down, positive slope going up. Example 3, the graph shows the distance a car travels over time. Find the slope of the line and what does it mean in the problem situation. So they've kind of noted a couple points on the line here. 2, 110 and 4, 220. This is a distance traveled. If you look, this is the distance in miles. This is the time in hours. So if we're trying to find the slope, it's change in y over change in x. So change in y, we went from 110 to 220. So if you subtract those, that's a difference of 110. Change in x, we went from 2 to 4. That's a difference of 2. Notice with my change in y, I started with 220. And so with my change in x, I started with the 4. If you divide that out, 110 divided by 2 is 55. So our slope is 55. And then the question says, what does it mean in the problem situation? If we look at our units, the y was miles and the x was hours. So when we did change in y divided by change in x, if we just add the units onto that, it's 55. The y was miles X was hours, that means 55 miles per hour that this car is traveling. So if you look at the try it, the graph shows the proportions of red and blue food coloring. Tailor mixes to make purple frosting. What is the slope of the line? And tell what it means in the problem situation. So you might guess I'm going to cross this out. Their triangle. They picked out a couple points. If I was just actually looking at the graph, there wouldn't really be a way that I would know this is the point 2535 because it's kind of in the middle here. But since they gave it to me, we'll go ahead and use it. If the points weren't given to me, 50-70 looks like a good point because that's right on the corner. Again, that one's not right on the corner. So 0-0 is probably what I would have gone with otherwise. And again, that tells me it's proportional, so we could do like we did previously as far as finding the constant of proportionality. But we'll just pretend like we're just dealing with these 2 points that they've given us. So we're trying to find the slope, so we'll do change in y over change in x. For the y's, we went from 35 to 70. So that's a difference of 35 if you subtract those. We started with 70, so that means for the x's we can do the same order. Change in x, we're going to subtract our x values. 50 minus 25, which is 25. So we've got 35 divided by 25. Normally at this point you could divide that out. We'll talk about that more in a minute. If you reduce, both of these can be reduced by 5, and that would be 7 over 5. And then if you look at the graph, this was red drops and blue drops. So that means we've got 7 red drops per 5 blue drops. Okay, so we could say actually 7/5 could be our slope. And then we just talked about the description. It means 7 red drops for every 5 blue drops. One thing about this, if you divided this out, which we would do a lot of times, we would say, oh, let's divide them both by 25 and get a unit rate. Well, if you do that, in this case, you'll get 1 4/10. And that means we have 1 4/10 red drops for every 1 blue drop. So if we have this food coloring and we're using this, drops of food coloring, if we try and do that, let's try and get 1 4/10 drops of red food coloring. 1, 2. Oh, I passed it up. Let me try again. 1, 2. There's no way we can really just get 1 4/10 red drops here. That's not going to work out very well. And so that's why in this case we would just leave it as 7 red drops for 5 blue drops. The key concept just recaps things again, talking about rise over run, rise first and then run. So in their example here, they went up 30 over 2, and they got 15 when they worked that out. If we look at the do you know how number 4, they're asking what the slope of this line is. Something different on this problem, none of the points are marked. So you get to pick any 2 points that you want, as long as it goes through that point for sure. So we might see here, this is the point 1, 3. Let's say we go with the point 2, 6. Technically could have gone with the point 0, 0 down here. Actually would be a nice point to work with. There's a 3, 9 later on. Okay, but just find any 2 points that are on the line. Change in y over change in x. So to get from 1, 3 to 2, 6, our change in y, we're going from 3 to 6. So that's a difference of 3. So we go up 3. And then the x, we went from 1 to 2. So that's going over 1. And you'll notice when I worked that out, I started with the 6 on the y's. I started with the 2 on the x's. So that's 3 over 1. And that's the same as 3. And if you look at the information here, what that's telling me, it's 3 $3 per pound of grapes. They didn't ask that question, but they could have. Number 5, the scale of the model airplane is shown in the graph. Find the slope. Now it says using y2 minus y1 over x2 minus x1. That's a different way of writing change in y over change in x. That's just subtracting y values and then subtracting x values. The little subscripts, those little numbers below, basically just means we have to go in the same order for the x's that we did on the y's. It's kind of like if we had x1, y1, and x2, y2. Okay, if that doesn't make sense to you, don't worry about it. Just understand these mean basically the same thing. So finding the slope here, we went from 3.5 to 6.10. So our y's went from 5 to 10. So that's a difference of 5. And our x's, we went from 3 to 6. So that's a difference of 3. So we went up 5 and over 3. Since that doesn't come out nicely, you can actually just leave it like that as 5/3. And then part B, what does the slope mean in the problem situation? What it means is we have 3 centimeters. Sorry, let's do it in the same order we had. We have 5 feet for 3 centimeters. This was talking about, it said it was about a model airplane. So 3 feet on the actual airplane. So we can just say it like this. 3 feet on the actual airplane is represented by 3 centimeters on the model. So this gives you a little bit of an idea of how to work with rate of change and slope.